but that is an after-school program. We have something called JSHS, the Junior Science and Humanities Symposium, which there is no longer a humanities component. This is a research competition where the students go to UC Berkeley and they present a paper or a talk, and they are judged on that. Our students will be talking about this. We coordinate that. We place students in internship programs. I'm sorry if the color is a little washed out. I will be speaking about research internships, and our students will describe that in more detail. These are internship placements that we offer over the summer. Of course, we encourage our students to find research internships, as Sreyas did, on their own. But we do offer, to some extent, a placement service. We have something called USA YPT, which is the Young Physics Tournament. And that is something that students work on throughout the year. That's coordinated by our physics teachers, and that's something that you might want to inquire about. We have Intel Siemens, which we coordinate, and we're going to start that in May and go for the entire year. Is this better? Okay. So we're going to start that in May. We're going to send an announcement out indicating that we are ready to give out information. We'll monitor all summer. I will send all sorts of guidelines. In August, we will have a workshop on technical writing, and then when the students return and they've written a paper, we'll be reading drafts. We'll have some students talking more about that. We coordinate Synopsys. Mr. Spenner will be describing the Santa Clara Valley Science and Engineering Fair, which many of you are very, very familiar with. We coordinate that as well. And then we run research expeditions every summer. The Harker Upper School Science Department offers a trip to Costa Rica, and we are alternating with Tanzania with the Arctic, which we will be starting next year, addressing climate change. Students will be traveling to a location just south of the North Pole, about 200 miles south, and we'll be looking at plankton surveys, ocean temperatures, etc. Okay, so before I turn the mic over, I just wanted to explain that a little bit more. Our research expeditions are in fact an opportunity to conduct research outside the classroom, outside a university setting, in a field setting. And there is a tremendous amount that you can learn here about unpredictability and failure and how to bounce from that. So it's a very, very interesting experience and opportunity. So what I'm going to do now is, I've already talked about the rest of the items on this slide, and we're going to continue on now talking about them in a little bit more detail, but letting the students run that. So let's begin with the research classes.
I'm Chris Spenner. I teach the research classes here. I'll just introduce them very briefly. We have two. One is Research Methods, which is an introductory class for sophomores through seniors. And it's for any type of student, whether they know they want to do research or not. The advanced research class is more of an independent study. It's one semester, but students can take it repeatedly. And it's much more student-directed. They set their own goals and use class time to pursue them. What I want to highlight, though, actually, is the Research Hub website that we have for parents especially. It contains information on most of what you're going to hear today at this panel. If to find it, you would go to the parent portal, and there's a link to the Research Hub on that page. So keep an eye on that. We'll be updating that with more information, important dates, schedules, descriptions of programs, that sort of thing.
So I wanted to talk a little bit about the 4-year experience doing research at Harker. I began my research as a freshman at Harker and have done research every year since. And so what I'm going to do is I'm just going to go through a little bit of what I did and then maybe some suggestions for what future Harker high schoolers would want to do. So I began research in 9th grade, and I conducted my research project in microbiology, and I actually worked in the Harker labs themselves. Mr. Spenner and Dr. Blickenstaff were my two mentors. And I spent a lot of time during my breaks, during lunches, during after-school hours, working in actually the Open Lab program, which had just begun that year. And I found that that was very valuable to work on my project and kind of get started and exposed to the whole research process. I'll expand upon that in the next slide. The freshman year project that I conducted, I actually entered into Synopsys, so I prepared a poster board for that and was able to compete with other students and kind of share my work with scientists from the community, and that was a very unique experience that I'm glad I had exposure to freshman year. In 10th grade, it could be advisable to start thinking about what you would want your project to be for the upcoming year, the summer before, and if you have the time and opportunities, then maybe even beginning the experimentation process, or at least the background reading material. So what I did was I also conducted my project at Harker Labs in my sophomore year. This one is more in the biochemistry field, looking at biofuel production, but I once again used open lab time and the space in the labs that was offered by Harker. I also took the research methods course, the introductory level, which Mr. Spenner taught. And that was a wonderful course to really give me not only the time to spend on my project and experimentation, but also I also received a lot of feedback and guidance from Mr. Spenner throughout that class, and it really helped propel my project to the next level from the previous year. In my experience, for this 11th grade, I actually conducted an internship at UC Santa Cruz the summer before 11th grade, and I did this jointly with a partner, Sachi Jain. The two of us, we worked in a microbiology lab at UC Santa Cruz, and we conducted a project throughout the summer, and then we ended up writing a paper on that and entering that in Siemens and Synopsys. So for Siemens, we wrote the paper, and for Synopsys, we had the poster board and presentation. And I feel that working at an internship, working at a university was once again another step up from working at Harker Labs, and it was a perfect stepping stone from what I had done before. It was a little bit more extensive, more time intensive, but it was definitely exposed me to the research at a completely different level. In 12th grade, I also interned at a university the summer before. I interned at Stony Brook University in New York. So it was once again working in a professor's lab, but this was a completely different professor. And some of the aspects of interning at a university level were the same, some of the basic ones, but I got exposure to interacting with different types of people, with all different types of background, and working in different types of environments as well. So that was a very valuable experience. I actually also stayed in New York throughout the summer, so I had the experience of being able to get to know students from throughout the United States and being able to live with them and make friends who also share the same passion for science as me. And my senior year project, I also wrote a technical paper and applied to Siemens and Intel from that. And while I didn't take any research course, it would be highly recommended to both in junior and senior year if you feel that you want the time and the guidance to for your research project that you're working on that year. I would recommend taking an advanced research course if you've taken a beginning one before, or if you feel that you have the experience and you're ready to dedicate more time to the project, because it really does help when you're preparing for these competitions and when you're just trying to work on your project and get the final results in. So as I mentioned, I conducted my first two years of projects at Harker Labs themselves. Oh. Yes, this one, yeah. That's okay. And while I began my freshman year, I really do think that it is never too late to start. I think the key to conducting research as a whole, and particularly at Harker too, is as long as you have the initiative to begin and you have the willpower to kind of dedicate enough time for yourself to spend enough time on the project and follow through with what your initial plans are despite setbacks, it really is possible to do research and be successful at research, regardless of what year you start. As Mr. Spenner and Ms. Chetty previously mentioned, there are multiple research classes offered at Harker, which in the research classes options are just expanding every year. And we have wonderful mentors for those like Mr. Spenner, who will devote a lot of their time to helping guide you throughout the process and kind of help you understand and help you through any of the struggles you might be facing. Also, the Open Lab program is wonderful. It really helped kickstart my journey as a researcher, and I would highly recommend it to anyone who is interested in starting a research project or needs some more time with working their own or wants some guidance from some science faculty at Harker. We also have at Harker this incredible opportunity for having other faculty, science faculty, actually review your papers if you're planning on applying to the Siemens or Intel competitions, which both require technical papers. These are like 20-page technical papers that you write on a project, and often it's really valuable to get feedback from as many people as possible. And for both the years that I participated, I've had mentors look over my papers and really provide some valuable insight that from a teacher's perspective and from someone's perspective who may not necessarily have been your direct mentor, but is an expert in the field, and thus has really great feedback to provide, and I feel like that really helped me as well. Now, if you're conducting research at Harker, obviously because it's only a high school, there are some restrictions with, like for example, if you're conducting work with biological agents or hazardous chemicals, the Harker only has a biosafety level of 1. So essentially that means that you have to stick with some of the least dangerous materials that you're dealing with. So I guess that does pose a restriction if you're working at Harker. Additionally, if you're looking at time to work in the labs, then you would have to really coordinate with its mentors and teachers who are here at Harker, because they're also taking their time out to supervise you and help you. So you would have to coordinate in terms of after school or between breaks, whenever you would want to work on your project. But I found that, especially when you're getting started, Harker really provides so many resources, both in time and with just materials for your projects, and the guidance of the mentors, which is truly invaluable. And I feel like that's a really great place to get started.
So when I first applied for a research program in my sophomore year, I found that it was really challenging to pick a specific program that I thought best covered my interests. But after I went through the process last year and also this year, I found that it was not really as challenging as it may seem. There are 3 main options for finding a program. The first way is to apply for a structured research program. This is usually like a summer-long commitment that's like 6 to 8 weeks long. Most of the time it goes beyond just pursuing a research topic. A lot of times it requires like faculty talks or guest lectures that brings you new discoveries and lets you connect with a lot of different people in your field. The second way is to connect directly with the professor, either by sending them an email explaining why you're interested in their field of research. The third way is to apply through Harker. We have several programs like SIP at UCSC. You can apply at your sophomore or junior year, and it is a great opportunity for you to basically, if you don't want to do like one of the structured research program, this is a great opportunity for you to find a research project. The structured research program, the application process usually consists of 1 or 2 recommendation letters from like a science or math teacher, a transcript, a resume, and several essays talking about your like interest in that particular research. Looking back at the process, I would recommend that you really plan ahead and look at each deadline and make sure that you have enough time to write all those essays out, because it's really important that you cover what you want to cover in those essays. You should also notify your teachers well beforehand, because you have to give them ample time to write a strong, comprehensive letter that covers all your characteristics. Lastly, those applications are usually due around January through March, so make sure you like write that down in your calendar.
So as Jason briefly touched on, there's basically two ways to land internships. There's one, either the structured program or through contacting professors individually. And it's important to remember, I think, like from my perspective especially, just getting into one of these structured programs is not a guarantee of success in terms of awards, and not getting in is also not a guarantee that you won't win anything. So for me, I went the independent route and contacted professors independently. And essentially, when you use this approach, you have to know exactly what you want, and or at least in a general area, what type of research you want to do and in what area. And essentially, it consists of just emailing professors. And in the email, you can't just say, for example, if you want to do a astrophysics project, you can't just email the professor and say, I'm interested in astrophysics. Ever since I was 5, I've looked up at the sky and wondered what the meaning of life is. That won't work. So you have to really look into the professor you're interested in, look at what they're doing, the research they're doing, and actually convey your interest for that field. And the interest has to be real. You can't fake the interest saying, and change it email to email saying, I'm interested in this, I'm interested in this. It has to be a genuine interest, because if it's genuine, it'll come out in the actual research you do. You're passionate for that research. And the emails don't, if you're emailing professors, don't email like 5 professors at once. Email them individually, because just you want to respect the professors as much as you can. They're extremely busy, and even if they get tons of emails like this from students all over the country who really want to work with them, and if they usually just don't even open the emails because it's it's pretty standard for them. So it's very important to email as many professors as you can, because out of 50 professors that you email, you'd be lucky to get 2 positive responses. Personally, for me, I emailed dozens of professors, got so many negative responses, and most of them didn't even bother responding at all. But all it takes is just one professor to email you back and say, yes, I'm interested, and then usually they'll follow up with an interview. You can go there, and some of the interviews might be technical, some of to like assess how proficient you are in that area. Some might just be, why are you interested in this? But either way, be very prepared, be knowledgeable in that field if you want to get in through a individual contact. And also utilize any connections that you may have. Connections are extremely valuable, because the main issue that a lot of these professors have is with taking on high school students is that most of them can only work for 3 months, and some of them might not be experienced enough in the area that they're researching. So if you have a connection that says, or a reference that you can get that validates your abilities, that might make them more inclined to accept high school students. And again, most of these professors really, they work with postdocs and grad students, and they might not have time for high schoolers. So that's why you utilize every connection you may have so that you can get an internship with the professor. And the application process in terms of, I think Jason covered this already, but if you want to go through a structured program, it's really important to stay planned and be very organized, because there's tons of programs, and each one has different requirements, different types of recommendations, they want the transcript mailed in a different form, so stay apprised of all of those. And going back to the contacting professors point for just a bit, it may seem very difficult to get one of these independent internships, but it's definitely possible. People do it. I did it, and it's not impossible. But you just have to keep trying and be persistent with it, because it is hard to get one. But if you email lots of professors, be very genuine in the email, and try and impress them, you have a good chance of landing one. So that's important to keep in mind.
So we've been hearing words like programs, we've been hearing the word internship, or research internship seems to be the big buzzword these days. I just wanted to clarify a couple of things before the students describe their experiences further. First of all, when you're applying for some of these programs, you first need to determine what you really want to do with your summer. Perhaps all you want is some type of immersion in at a university, in a department that is teaching you actual content at a college level. Perhaps that's what you're interested in, with a little bit more skill development in a laboratory setting. So not really a research project that you're independently doing, but just kind of getting your feet wet and maybe learning content at a higher pace. That would be an academic program that you would be applying for. So when you apply for these programs, read carefully about what they're offering. These are often fee-based, and you may have to go to another university or to a university in another part of the country. There would be housing, there would be a program fee, etc. That's different from a clinical internship, which I am going to be posting for juniors in the next couple of weeks. We have one through Kaiser Permanente. This is also not a research internship. This is an opportunity for students who are thinking about medicine as a career, and they don't know too much about what it's like to be a doctor, and they don't know too much about what are all the different fields in medicine. So through a great partnership that I have with Kaiser San Jose, there is a 6-week program that we offer, and you essentially go from clinic to clinic. You do get lectures. You do go ahead and sometimes there are small, very short research requirements that you do. You learn a little bit about what it's like for that department, and then you move to the next one. You may observe operations. You get a really close look through the eyes of a doctor at what it's like, the sort of the day in, day out. this is a pretty restricted program. There's only 4 to 6 candidates that actually are accepted, and this is something that's done through Kaiser San Jose. So I'm just merely the liaison here, but if you're interested in that, that's something for you to look forward to. And then, of course, the research internship, which is what the students have been describing, where you are in a lab working with a mentor, which is probably a graduate student or possibly with a PI. You drop in, you spend 6 weeks, 8 weeks conducting an independent project. Some of our students then continue perhaps going while even school is in session, sometimes during weekends. But essentially, you get sort of the real experience of what it's like to be a scientist, to carry out a research project in that research setting. So I hope that helps to sort of clarify what all the different opportunities there are and what the terms actually mean.
So when you actually enter an internship, it can be kind of intimidating. I know I was pretty intimidated both times when I went to universities because the people who you're working with and are surrounded by are much more experienced than you in research and just in life in general. They're much older than you. They could be like postdocs, graduate students, or professors. And they just seem like they have so much esteem and they have so much I guess, prestige to them, but and none of which you have. But I think it's important to understand that you are there as a high school student. You are probably one of the youngest students there, and that you are there, and the purpose, your sole purpose or your main purpose, hopefully, will be to learn and to gain experience, and that the professor or the mentor of the lab has accepted you into the lab for a reason, because they know that you will add to the lab, but that also that they will be able to provide you with some sort of mentorship. And I think this mutual understanding is very important when you go into the whole experience, so that you don't ever feel that you are lacking in something, but you also feel like that you bring something to the table. So I found that one thing that was really, really important for me, and that I discovered kind of later on, is just to really not be afraid to ask questions, to take initiative, to keep pressing to get things done when you wanted them done in the lab, because you're kind of like the tiny little baby in the lab when you go there. But if you show that you're determined to get whatever it is that you want done, that you're determined to work really, really hard and to help the professor, but also to get their help, then people will start to recognize that, okay, this is like somebody who knows what he or she wants, and we're there to help them, and that really, really helps with making progress in your project. Because I know research can be a very slow process, but as long as you stay determined and you're willing to take that initiative, you can really continue to progress then. Also, it's important to not be completely it's more of a professional environment than like the high school, and you're interacting with people who are maybe at the university level, so it might seem a little bit intimidating, but it's important to not completely put up like a facade and be like super polite and try to always impress them, but maintain a level of collegiacy, I guess, and try to like allow yourself to be to show your own personality as well while you're there in your internship, because it's a lot of collaboration that goes on between you and the other people in the lab, and only when you are truly like who you normally are, but also maintain that sort of work ethic and that work environment, will you be able to get the most of the experience.
So one of the first things you want to do in a research internship is to look at what you want to get out of the internship as opposed to what your mentor wants to get out of the internship. Typically, a lot of students want to, at the end of the internship, have a 20-page paper ready for Siemens or Intel, or at least have the data and the results necessary for that paper. But a lot of mentors don't know about what you think of those competitions. Some of those mentors won't even know that these competitions exist. And some mentors may not want you taking part of their work and applying it for your own competitions. So you need to clarify first that you actually want to do these competitions, and you're going to be taking perhaps part of their research as part of your paper in those competitions. As part of an internship, you have a lot of advantages because you have access to university labs, and your mentors have access to a lot of resources that you don't necessarily have access to, and you should take advantage of that as much as possible. For example, I was able to get access to a few papers that Harker's databases don't have access to. I was also able to get access to some copyrighted programs that my mentor had written previously that helped me in my project and solved some problems that I wasn't able to solve on my own, and this is really advantageous for you. Another thing that you should use your mentor for is help when you're stuck on a problem, because a lot of these problems are hard problems that maybe you aren't expected to solve or you can't solve, but solutions already exist that your mentors know of, and it's very useful for you to be able to talk to your mentors for help. And then the most important thing for you to do in a research internship is to keep very close track of everything that you do throughout the internship, especially if you want to come out of the internship at the end with a paper that's ready for competition at either Siemens or Intel, because you don't know what you're going to end up putting in that paper, and you're not going to be able to remember the most important data or your exact details of your experimental methods when you're trying to write your paper a month or 2 months later for Siemens or Intel during the school year. So you should keep a very good lab notebook. It's also true that the lab notebook is required at competitions like Synopsys, so you may need to present it there.
So I'm going to be talking about mainly the research experience. So I worked at a lab in Stanford, and I think like one of the things, like the culture of the Stanford lab, is that the mentors are usually really busy. So a lot of the work you're going to be doing is your own, and sometimes that might be really intimidating. I came into it thinking that the mentor would help me a lot more than they did, and I'm kind of happy in hindsight that they didn't help me so much, because I can take more pride in my work, because even though a lot of the solutions I came up with were like suboptimal or not the best, at least the work was my own. So if I don't know, like there are a lot of other programs that the mentors may be more involved, but in some cases you may get mentors that are really busy, like for example, writing their own applications for grants and things like that. So it took me completely by surprise, and I had to. There was a lot of like inefficiency in how I worked, but the most important thing for me was like persevering through the entire process. And the other big thing is that the types of people you're going to be interacting with in these labs are usually very, very smart and very driven people, because they obviously care enough about science to be working and spending long hours in a lab. So it's important to try and foster these connections. For example, now my mentor and I are really good friends. We eat dinner together sometimes, but I don't know. They're really interesting people. Right now they're giving me advice on like what to study in college and stuff like that. They have a lot of information that they can give to you that's not just related to research. And I guess it would also help, like for example, if you want to branch out to different labs, if one of your people in your current lab can reference you to the person in the other lab in that same university, that might help. So you have to keep you should keep talking to your mentors, because they may just be your mentors for your project, but it would be even better if they're your mentors for life. And another big thing I want to talk about is staying on the same page with your mentor. So my mentor, for example, traveled a lot, and at first I didn't really know, you want to know your mentor's schedule, and I didn't really know my mentor's schedule. I never really thought that would be an issue, but then like when he leaves for like 3 weeks to Korea, and I have like no one to ask for help if I get stuck, then you obviously have a problem. Or for example, if you have like a competition deadline, he should know about these deadlines, because like for example, if you want him to like look over your paper right before you submit it, he has to be in town before you send him the paper, because otherwise they're not going to respond to their email. So you always want to be on the same page. And the biggest thing I learned about research, and it's also a very frustrating thing, that you're not going to get these solutions the first time you do it. It's not like in a classroom where the problems are very idealized. There are lots of real world considerations to take, and you're building your knowledge from scratch, because most of you are going to go into fields that you know nothing about. I didn't know much about medical imaging or like the programs. I was very weak at programming before I entered in. And a lot of things will go wrong. I often got really frustrated, and especially because my mentors were very busy. So I think if that happens, I think one, you should keep persevering and take pride that it's your own work and not like some canned project where everyone else is doing it for you. You're presenting your own stuff, and it's a natural part of being a scientist, and that's like where a lot of the learning comes from. And the other big thing I think is that like you should try and confront your mentor if you really need help. Like for example, my mentor gave me a very open-ended project, and I had to do all of the decision making and deciding what to investigate and things like that. And at a certain point, like I didn't really know where to go to next, so I asked my mentor if I could talk with him for like half an hour on how my project was going to evolve in like the next few days and things like that. So you shouldn't be afraid to confront your mentor, but you should also keep your mentor like in good standing with you.
Okay, so I'm going to talk about writing the technical paper. So this is one of the most important parts, especially if you're going to, if you're looking to enter a competition like Siemens or Intel, because this is where your work is presented. You might have to write other essays or something, but the focus is on what your work is and how you're going to present that and like give it across that you've done something interesting. So I think the most important thing is to begin early. You should start researching definitely during your internship. Like save papers. Your mentor will send you papers. Like make sure to read them through, save them, know what you're talking about, and know early and like know through the whole thing what you're actually doing. Don't get lost in the process. You want to start early, so you know write down your methods. Like I think Vikram mentioned, keep a lab notebook. And it'll make the overall paper writing experience much easier if you just have a sort of clear vision throughout the whole process what you want out of this. Yeah, okay, so once school starts, definitely someone talked about Harker faculty readers. They're really, really helpful in reading your paper, get feedback, get constant feedback from your mentors, your readers. Obviously, don't bother them too much. They're all very busy people, but like definitely they're a resource. Even you know your peers, if you're an internship group, your peers, grad students, everyone else in the lab, they're definitely a valuable resource for you. In terms of formatting, your paper is a presentation. It's not just a collection of words and graphs or something. Learn like LaTeX. It's a markup language. It's very useful for making your paper look beautiful. I didn't use it, but like honestly, it makes your papers look gorgeous. But what's really important is that you know how to present your data. You don't want to have tables and tables of useless data or just graphs that don't really mean anything. Like if you're going to take up space with like a full-page image, like make sure it deserves that space. Make sure you know what you want to like convey, and that you're doing it well and that you explain everything very well, because that's what the judges are looking for if you're going to submit this to a competition. Next slide. Yeah, so just more general tips, I guess. You can definitely go out of order when you're writing a paper. This isn't like an English essay or something. You know, you can write your methods first since you know you're doing that. Introductions and stuff like that can come afterwards when you like do more research. So don't be afraid to put your paper together piece by piece. Don't be stalled on one part of the paper just because you don't know what like this term is or definition is. Research is so important. This is a research paper. It's not just your work. It's you're building on the work of like hundreds and hundreds of other people before you. Make sure you acknowledge that. Draw the line between your work and your mentor's work. All these competitions will ask you, what did you do yourself and what did your mentor do? Obviously, you don't want your mentor to do everything, but you also don't want to claim credit for the stuff that your mentor did because they've spent a lot of time and energy on that, and they deserve credit for that too. I guess the most important thing is to like be excited about your research. You know, you don't have to be curing cancer or curing AIDS to have like a really interesting project. You want to have a project that you're interested in the first place, and you have to convey that in your paper. Don't be like, oh, my results sucked, like sorry, this isn't conclusive at all. Like you're doing work, you're advancing science, and this is like the most important part, to be excited about your work and to convey that in your writing. So yeah.
Okay, so in addition to writing technical papers for competitions like Siemens and Intel, other competitions will ask you to present your work in a different format, and the most common are through oral presentations or poster presentations, and these are generally presented in a very different manner than the technical paper. The technical paper will generally include like all of the work that you've been doing, all of the important graphs, and you usually use more jargon, technical jargon, because of the judges will generally be from your field. But for oral presentations and poster presentations, the audience is almost always completely different. For oral presentations in particular, sometimes you'll have just a panel of judges, but other times you'll have an audience like the one right here, which includes like some people who are in your field or other people who are just your parents and friends and may have very minimal contact with your field. So for these types of presentations, you should learn to adapt to your entire audience. So avoid technical jargon, kind of give enough background that anyone in the audience can quickly pick up on what are the key terms, what they mean, and so that they have a good idea of what's going on, even if they don't have much background in the field. And but at the same time, you also want to address the judges who you might have in the room who do know more about your field. So kind of have to strike a balance between those two. And then for poster presentations, These ones are usually done, this is the format for Synopsys, for instance, and these are usually either like one-on-one or you with like 2 or 3 other judges who come by to see your poster. And for this, the key thing is to be flexible because, again, although almost all of them will be judges who come to you, they will come from a very wide different backgrounds. And some of them will have already looked at your poster and know a lot about it. Other ones haven't seen it at all. So really just have to be flexible and vary your speech and what you're going to say according to who comes to you. Sometimes it will have to be a lot longer, other times much shorter. Sometimes you have to give the background, other times you don't. So just know who comes to you and adjust it accordingly.
So a few words about Synopsys. This is the Santa Clara County Science Fair. Students who do well go on to the California State Science Fair or to the Intel International Science Engineering Fair. There are other kind of tangential competitions that are related to it they can get awards for. We just discovered this year that they're no longer holding the awards ceremony at Great America. I was very sad about that. But there are other reasons to do Synopsys besides the Great America trip. You get a chance to present your work to judges. Part of being there is that you're talking to other people who, and across a wide range of backgrounds who've also done science. So it's a great experience in and of itself, I think. The rules for next year, as far as sponsorship, it looks right now as though they are changing. So my advice right now is to stay tuned. We might have to change how we do our sponsorship in response to the changing Synopsys rules. So the best advice I can give right now, well, 2 things. One, again, keep an eye on the Research Hub website. We're going to keep that updated as we change our policies. Also, come see me as early as possible once you have an idea for a project and you want to enter it in the science fair. If you wait until that last week before the Harker deadline, it's very unlikely we'll be able to sponsor you.
So like Mr. Spenner mentioned, there's at Synopsys, it's important to know exactly what the judging criteria are in order to be able to best perform at the fair. So it's very important to know every inch of your project, and the type of presentation you should be able to give is not where you have to keep looking back at your poster board to see what some detail is or the other. Know every inch of it and be able to answer any questions that come your way. And the thing about Synopsys in particular is that some of the judges will be in different fields. So it's basically like a layman's presentation. And you have to know how to tone things down, then what to omit, and which parts to include and which parts to highlight. And then some will be complete experts in your field. And they'll ask the really tricky questions to try and occasionally trip you up and see how much you really know. And so the depth of your knowledge will really come out in these interviews. And you need to. It's very important to make sure that you know every single detail about your project, and not. So not everyone that enters into a research competition will have to worry about presenting their project to judges. Judging only happens at the Synopsys Science Fair and a couple other fairs, but mainly the main point is you need to be able to effectively communicate the research that you've done. And communication is key in like Intel, Siemens, Synopsys, all the research competitions. How you communicate your research is the most important because you can do amazing research, but if you don't communicate it well, you're not going to go anywhere. And in communicating it, it's important to highlight specifically the goals and motivations, as well as the applications of your research. Why is it important? Why is it relevant? Why should anybody care? That's the most important part in communicating research. And also, it's all right if at the end of your research internship, you don't have like a answer to the question. It's a lot of the judging focuses on the process and how you were thinking in this process and how innovative your ideas were and how you approach the problem. A lot of it's a strong point and in a lot of these competitions, and most people think that if you don't have like a defined conclusion, then you did something wrong. That's not always the case, because as long as you used a very novel approach and really tried hard in that area, that can also give great results. And judges also focus a lot on the potential of projects. So I think, like Sreyas mentioned in his talk, that the validation steps weren't there, but I mean, still the potential of the work, even if you don't take it from 0 to 100% all the way, no one expects that. It's, you take it one step, and that's the nature of research. It's a step-by-step process, and eventually it's completed. So judges look a lot for potential. And yeah, also some of the typical Synopsys questions, what made you choose this project? Why are you motivated? Where did you do your work? How long did you do your work? Because, and it's important, these questions might seem like cliche, non-technical questions, but it's important to have answers to them, because if you can't explain to a judge why you're motivated to do your research, you're not going to do very well. So you need to know the answers to these questions and really and practice them as well. And lastly, I just wanted to touch on one thing that Sreyas said in his slide. Research doesn't generally tend to be a fast-paced process. It's a very slow process, and it's important in an internship that you really need to drive that process. And for me especially, my mentor was working on so many other projects, and she had basically 2 minutes to focus on my project. So I really had to go to her and be the instigator of a lot of things and really drive the project and make it more fast-paced, because you have deadlines to meet. You need to submit the paper by the deadline, and if research is very slow and it takes multiple years, so you really have to drive that process and speed it up if you need to. Next slide.
Another competition you can compete in is called JSHS, or the Junior Science and Humanities Symposium. And for JSHS, you first submit a technical paper, and that's the first round of screening. Then about 50 or 60 semifinalists get chosen for the semifinal round. And for that, you give an oral presentation to PowerPoint to a panel about 12 or so judges. And from there, about a dozen students get chosen for the regional finals, which is the actual symposium. And for the symposium, you present your presentation in front of a crowd of about 250 people, including judges, high school students, teachers, and all sorts of people from the region. And it's actually a very exciting experience, because it not only includes the competition component, but also includes other fun activities like lab tours. It's held at a different place every year. So when I did it last year, it was at Berkeley, and we got to tour some of the cancer research labs at Berkeley. And then you also get to network with a lot of people. They bring in speakers, and you get to meet a lot of other high school students from the area who share the same passions as you. So it's a great experience, not only if you're interested in competition, but also just to meet other people and to get more exposure to the scientific field that you're interested in. Next slide. Okay, another competition that I'm sure you've all heard of is the Siemens Competition, and this one is, unlike JSHS, it's purely based on a technical paper. There are no additional essays that you have to write, so it's just based on a it's usually about a 18 to 20 page paper, I think. And the Siemens Competition is open to all high school students. If you're a senior, you can compete either as an individual or in a team. If you are in 9th through 11th grade, you have to compete as a team. And for Siemens, I guess the one thing that I would like to emphasize is that the deadline is usually on October 1st, I think. So that deadline comes up very quickly right after the summer. You only have about a month after school starts to work on your paper, and I think a lot of students really underestimate how long it really takes to write a research paper. I've heard some people saying that really writing the paper is like another internship in itself. So I would highly recommend that you, like Stephanie said, start writing parts of your paper that you can over the summer. If you're interested in competing in this competition, write down your methods while you're working, and also keep a detailed notebook so that come September, you already have like pretty much all your notes down, and you don't have to like think about what you did in June, and you still have like a record of everything. And I guess just also plan ahead, make sure you have like a schedule for when to finish it by, because the deadline does come up very quickly.
So I'm just going to talk about the Intel competition. So the Intel Science Competition is a seniors only competition. You probably know about it because it receives a lot of publicity. The Intel competition, similar to Siemens, is the first round involves you submitting a research paper. So it's unlike Synopsys where you're presenting directly to the judges. They're going to be reading a 20-page paper, and the it's very similar to Siemens in that one, as I said, it involves a paper, but also the rules about the paper and the length of the paper and all are very similar. So people often take their work from Siemens and then build upon it for the Intel competition. And the deadlines are very close together. So if I highly recommend, if you want to do Intel, you should also do Siemens because I mean, you may as well do one, or if you've already done Siemens, you may as well do Intel. And also doing Siemens before you do Intel is useful because it's like a free trial run, I guess. You get to see how judges react or how well you do based on what you turned in. I know that from when I submitted into Siemens, a lot of my research was done after that. So I spent so much time on trying to like improve my paper, rewriting a lot of paragraphs and things like that to make things a lot clearer to understand. And I added like new data, new experiments and stuff like that. So if you want to do Intel, I recommend doing Siemens. So from the paper itself, they choose the 300 or I think it's like 300 semifinalists out of around a pool of 1,800 applicants. So the semifinalists will each be given like a prize total of $1,000. And then what you do is you sit and wait and see if you're chosen as a finalist. Within that phase, you don't actually have to do anything. You'll be judged as a finalist based on your paper. And sorry, another thing I forgot to mention is when you're applying to Intel, you should start working a long time in advance because it involves lots of essays. So it's very similar to a college application. In fact, I think the essays, the amount of time I spent writing them or the volume that you're turning in is a lot more than any college application I wrote. So you should start working on it in advance. So based on these essays, you're chosen as semifinalist, and then you get a phone call the night before the finalists are released to notify you that you're a finalist. And what finalists do is that for the top 40 semifinalists will be invited to fly over to DC, where they'll meet with they'll meet all the other finalists, and then they'll meet up with lots of different scientists from like the government or from like the Intel Corporation. You get to have dinners with them. You listen to people from NIH talk about how to receive grants and like this whole process of research. I got to meet Obama and things like that. So I got to meet my congressional representatives. It was a really fun experience. And the actual Intel judging at the finalist level comes in two basic parts. The first part is judging interviews. So judging interviews are basically very similar to the tech company questions you're going to get at like Intel or Google if you're applying for a job. They will ask you like curveball questions that you will never have heard before. It's very hard to prepare for. And they usually come from like random science topics. And these science topics, usually you will have had like some experience in them in the past, so it's really important to try and like remember them, or when you're in class, you should pay attention to things or revisit information. Like a common question is like, how does a potato cell work? And even though it's like a pretty basic thing, usually you don't remember it, even though it's like a 4th grade science project. You should have a good grasp of the fundamentals. Other questions that come to mind are like the really random questions, like how do you regulate the insulin dose of a diabetic while he's undergoing brain surgery? Or the first question I got asked is how do you build a mammoth? So there are like lots of really cool questions, and the idea is not to see whether you can actually get the correct answer, even though it's obviously good to get the correct answer. But a lot of these questions don't have an exact answer, and they want to look at the path you take through to arriving at whatever answer you do. So even if you don't know the answer to the question, you should still try your hardest to answer the question, and you should always think out loud so that they can see your thought process. And the second part of the Intel competition is the poster presentation. So this poster presentation is basically where you present your poster in the National Geographic Society Science Fair, and all the judges will come visiting your poster. Usually the judges that visit your poster are judges whose expertise is somehow relevant to your field. So I had a radiologist visit my project about PET scanners, and I had like a physicist and people like that. So the poster presentation is slightly different, I think, from stuff like Synopsys. So it's not like a formal poster presentation where you can just go through a run through and then the Q&A will happen. Usually the judge will like interrupt you between, or like, so one poster presentation to one judge can be completely different from your presentation to another judge. You want to spend the time you spend on a certain topic will be variable. So it's a very informal type of presentation. Most of the judging comes from the judging interview. And then the final part about Intel, which is probably one of the most fun parts, is where you present your research to the public. And I didn't really expect many people to like care that much about high school research there, but the amount of publicity they do is so much that like all kinds of people start visiting. You get like scientists in the local DC area visit. You get people flying over to DC to visit you. Also, before the awards gala, you have people visit. They have another fair there, and they all visit you. So it's a really great experience. I thought the best part was meeting the other finalists and the judging interview questions, because now I feel like after going through all of those grueling judging interviews with all the curveball questions, I feel a lot more confident that I'll be more prepared, like if someone tries to ask me a similar type of question. So it's a really big learning experience. And I think the biggest thing to remember about Intel is that even though you're there for a competition, you shouldn't think of research as a means to being successful in like Siemens or Intel, but I think research should be like, it should be an end upon itself. So everyone there should be there because they're doing what they really enjoy. And the environment in Intel is really great because a lot of the people there have like already gone into colleges, and it's just all about like sharing your ideas and appreciating other people's research. All of their projects are really unique, and I think it's one of the best experiences I've ever had in my life going to DC. Even though I didn't place in the top 10 or anything, I learned a lot from it.
You know, after listening to these guys, you don't need to hear from me as a parent. I think the best thing parents can do is stay out of the way. We've got great students who not only can do great work, but can communicate really well. And I think that's part of being successful in long term. So what I thought I'll put together is a view very quickly that many of you might recognize as characteristics among many of us parents. And this is meant to be humorous, so please don't get totally shocked. These are the things that, if you can click once more, we really shouldn't be doing as parents. You know, our job is to primarily stay out of the way. Then click once more. One more, and one more. Thanks, yeah. So I think our job is to take the students and provide support and encouragement. That's number one. I think the more we try to interfere, more we try to provide guidelines or structure things for them, I think the less successful they're likely to be, because these students are self-driven. You heard the word initiative, you heard the word persistence, you heard the word perseverance. I think those are the things that make a researcher successful, and the students are there. So first is support and encouragement. The second one, where we could, on the sidelines, provide some value to students would be as they look for, and you heard a lot about how difficult it might be to get that acceptance for a research project, is to help with the networks we have. And just quick introductions, not necessarily insisting on getting selected or pick my child because it's my child, but really to make that door open for them. And the last piece is you might need, in some cases, some of the students don't need this, but in some cases there are some timelines and things that absolutely are rigid, and there's no flexibility. You might want to just monitor that so that the students don't miss that, because there is a lot going on for these kids, and especially as they get to the fall of senior year. It's college applications, you're trying to apply for Siemens, you're trying to apply for Intel, and of course the regular coursework, because in some cases the APs might be quite extensive. So those are the three things I would say, and I'm happy to do Q&A after that.
Well, we've tried to offer you a very comprehensive and informative wrap-up to the Research Symposium, so that after this session, any questions that you may have had should have been answered. However, if there is a question that you'd like to ask of the panel, we would certainly be willing to take those at this time. Yes? So the question is there any analog to what is available on the parent portal? Is there something on the student portal?
Currently there is not. It's a brand new website. We haven't really published it previous to this year, or advertised, I should say. Probably we should put it on the student portal. Yes, that would be good. It's information that's just as good for students as for parents, timelines, and just a list of all the opportunities that we offer for research students.
Yes.
Yeah, thanks a lot all for a very informative session. So I wonder whether the presentation slides and also the video recording will be made available on the parent portal.
So the company that is videotaping this, Create TV, is going to be offering it on their cable television network. I'm at this point cannot answer as to whether it'll be available off of the Harker website or not, but I'm certain we will have a link to the cable TV, and I will make sure that that is announced. And we will have these slides available as well, linked off of what is currently the parent portal. We'll see what we can do about the student portal as well. Yes?
Oh yeah, so I know there's like a lot of students are interested in taking like AP sciences, like bio and chem, but there's a summer prerequisite. So like, how do you manage like, or how do you choose between research and like AP courses, for example?
Mm-hmm. That's a really great question. I'm going to answer the first part of it, and I'm going to get Anika Gupta to answer the second part of it. So the question is that AP biology and AP chemistry are almost a full year program for our sophomores and our juniors, where we have 4 weeks over the summer and 6 weeks for biology, 4 weeks for chemistry. So how do you do an internship project as well as do AP courses? So I think that what you need to do is you need to take a look at what your own personal goals are. If in fact you wish to pursue research, if that is what you are passionate about, then an experience in a laboratory setting far exceeds sitting in a classroom for 4 hours a day for your summer. That is my own personal opinion. So what we've done as a science department is we've offered you the opportunity to take AP chemistry and AP biology at different times in your academic plan, so that you can still try to do both of those if you are able to. So I'm going to get Anika to use her example.
So I actually it was a really difficult decision for me. The summer after my sophomore year, I could either participate in a research internship or take AP biology, the introductory portion of it over summer. And it had always kind of been my dream to take AP biology, and because I really loved biology. But then I started to really fall in love with research as well. And it kind of following the same lines as what Ms. Chetty said, I ended up deciding to do the internship. And I'm really thankful for that, because not only am I currently taking AP biology, so I didn't miss out on that opportunity, I still could take the course later on in high school, but the experience I obtained in the lab was so unique and so eye-opening that it's not something you can obtain sitting in like the four walls of a classroom, sitting in a desk or reading from a textbook. It's really interesting sitting and learning in the classroom, but getting that hands-on exposure and getting the real-world experience was something definitely I think it was really unique to have as a high school student, and getting that early on was I'm very happy I made that decision. So it's kind of weighing how much do you value getting that hands-on real-world experience, and are you okay with maybe delaying taking the AP Science course a year later, which is what I did.
So just to comment on that process, the timeline I think sometimes can be challenging, because the AP courses you got to sign up in January, and internships you don't get to know till late March or April. Do you have can the science department come up with some kind of solution to address that issue? Because you're going to apply for internships, you have no clue if you're going to get one, or you're going to get one you like, that you might want to decline, but then it's too late to sign up for AP. Those are the kind of challenges that we faced.
Sure. So I think that it is possible for you to, and I understand that, of course, the time at which those decisions are made are by the internship folks, that's completely out of our control. So you are right. Generally, the decisions come out in March or April. It is possible for you to change what you have registered for. So if you've registered for AP Biology, for example, you would then register for honors biology. It is possible. There are enough spots open, but that's the track that you would have to take. So it's not as though you are not able to take an honors level course. That's what you would have to do, is to drop down. But I just want to re-emphasize that it's hard to get a research internship. And if someone invites you into their lab, you've got to really think about that. That is a golden opportunity. And if research is your passion, if the child truly wants to do research and it is not something that is being driven by potential college applications, but instead because they're truly passionate about it, then I think the decision is easy.